Hello everyone, welcome back to the verification lab. Imagine you are designing a digital circuit. You have wire connecting the component and you have register storing the value. Now here comes the question. Are these two things the same? The answer is no. That's exactly what we will understand today. In SystemVerilog, everything revolves around two main concepts. Think of it like net is equal to connection and variable is like storing the value, like memory. And if you mix them up, your design and test bench can behave differently. So how they differ? They differ in how values are assigned to them, how signal are driven, and how hardware are modeled. What is a net? Let's say you connect a wire between two modules. The wire is a net. So it represents a physical connection wire. It does not store anything. It just passes whatever signal is driven. So if a module drives one, net shows one. If one drives, if no drives is happening, it shows Z, means high impedance, or you can say floating. So it immediately reflect driven value from the source. And some examples are wire and try. We have many more example, but we are rarely using. Most of the common usage are wire and try. So if I take a real life analogy, think of it like a water pipe. It does not store the water, it just carries wherever flows through it. That exactly is how a net behaves. Now imagine multiple sources connected to a same wire. Yes, that's possible in hardware. Net support multiple driver and final value decision is by resolution. So NAT can drive continuous assignment, can have gate output as well as module ports. Cannot be assigned in a procedural block. Procedural block are always or initial. So NAT are basically driven, not stored. So you cannot use NAT inside always or initial, that is procedural block. We have discussed earlier about the multiple driver characteristics of the NAT. So it is resolved by function. What is a variable? Now let's switch to another scenario. You have a register that store a value, that is variable. So it represents storage elements, value holder, assigned using procedural block. So procedural block are those blocks in which code execute sequentially. Initial, always, task, and function are those blocks. So we can say it remember the value. It is updated step by step inside procedural block. If I take a real life analogy, think of it as a notebook. You write a value, it stays there until you override it. That's the variable. So now let us take some example. Logic, bit, int, byte are commonly used variable. So let's move to the next slide, and this will explain the variable key characteristics. So variable are assigned in an procedural block. So what are those blocks? Like inside, always, task, and function. Can be written by multiple procedural block. So in a multiple procedural block, you can write variable. And the last assignment wins. Can cause race around condition if multiple block write. Same variable. So if two blocks write the same, we can have a race around condition. Now let us see time zero behavior of both nets as well as variable. This is very interesting. So when nets changes from Z to any value, it does trigger an event. But when variable change from its default state to any value, it will not trigger an event. So it is very useful in debugging. Then we move to void data type. Void means no value. Something you write a function but you don't want to return anything. That's where void comes. So think like this. It is a function that does not work and exist. No output, no return. So used with function that do not return anything. And if you see the syntax, function void display message. So here data type void tell us that our display message function has no return type. So let's go through some rules that void follows. Cannot assign its return. That means we cannot assign the return value to any variable. Or we can say cannot use void like data type in an expression, data type variable or identifier in any expression, and used only for task like behavior in a function. Or we can just say just to perform an action. Now let's move to the bigger picture. Now imagine you are dealing with a multiple data, not just one or one variable. You need arrays, but SystemVerilog gives you two types, packed and unpacked. So let's see what is the difference between packed and unpacked. Imagine a bus line of 32-bit OR. All bits are continuous, stored together, treat as in one unit. This is an packed array. So we can say memory layout is continuous, treated as a single vector, and the declaration is before the variable, and data type only vector based. So we can say this is an packed array. Now let's move to understand the unpacked array. Now imagine a list of values. Each element is separate, can store anything. This is an unpacked array. So we can say memory layout not guarantees to be continuous, but in case of packed, it guarantees to be continuous. Treated as a collection of element and declared after the variable name, and any type of data can be unpacked. So we can see use cases, packed use cases like bit level operation, while unpacked is for memory or data storage. So in summary, I can say packed arrays behave like a single OR carrying multiple bits, while unpacked arrays behave like a collection of separate storage elements. So this is the last slide, and it is the visual representation of packed and unpacked. So you can see first the packed array, logic 7 down to 0 data. So it can store 8 bit of data, where data values are continuous vector. These are located in a continuous manner. You can access them by using the index or by the range. Here we are accessing the range 7 to 4, 7 down to 4, and that we are accessing single element by data 3. Let's move to the unpacked array. So unpacked array, you can see we have defined logic data array of 8 location, and you can see this location can be continuous as well as sparse. So it is a separate element, and also we can access like data array 3. So we can access individual with the help of an index. So we can combine both of them, and we can say we have a memory. So it is defined as logic 7 down to 0 mem 4. So this is the basic understanding of packed and unpacked. As of now, I am explaining data type lecture, so I am not going in depth. When I will start SystemVerilog arrays, I will go in depth of each and every topic and explain you. So if you got help from this lecture, please do like, share, and subscribe to the verification lab. See you in the next video. Thank you.